Welcome to my channel. My name is Engineer Ahmed Alamir, and this is my channel for electrical courses and services. So we will compare today between types of connection, induction, our three-phase motors, and how to start this motor. And this comparison is very important for every controlling engineer, or every one who's work in control engineer system. So we have more common, especially in connection in the all of types. It's a direct online motor starter, and a star delta starter, and soft starter, and frequency inverter. Okay. For the block diagram, we will find the first direct online motor starter. It's just direct connection with a three-phase motor, and for star delta we define it as it's starting with a star connection, then the delta connection. And soft starter, we talked about the soft starter for a long time, and talked about the thyristors, and today we will find what is the difference between a soft starter and a frequency inverter and a direct online motor and a star delta within everything. Okay. And the frequency inverter, we will find the inverter which is converting the signal and controlling it by frequency. Okay, so when we see the voltage curve, it's just from 0 to 100% connection directly in direct online motor, and we say it's very dangerous for the motor and for cables, and it's may if the cable not qualified to find the way to standing from this very fast starter, it may explode. That's real. Okay, for the star delta, we will find that we reach a half proximity, half extremely of the 50, more than extremely 16 percentage. Then we will get this step to reach another percentage to reach 100% of the voltage curve. And for the soft starter, it makes his efforts to starting from 13 percentage, maybe it's make a 14, maybe it's more, maybe less, I don't know. You just controlling on the soft starter how you control for this minimum voltage when you start, and it's softly starting to reach 100% for the voltage curve, but not starting from zero. You have to show this part is very important. You have to know that this not starting from 0 to 100% softly. Okay, when you see that, you will find it starting from 0 to 100% softly for the frequency inverter only. So the only one who's starting from 0 voltage to 100% is a frequency inverter, but the soft starter never starting from 0. Okay, that's you have to hand. This is important to you. Loading on means at a startup. Okay, that's high, and for star delta it's medium, for soft starter low to medium, frequency inverter it's low. approximately low. For the next thing, you will find the curve of current, and it's so important. We just do these types for starting current, which is very high in the direct online connection. And when you see this direct online connection and the current curve, you will find the direct connection of the current and reach the highest of the current within 6 times the maybe 8 times for the current which is related. It's very dangerous thing for the motor coils and for also the cables. It's very dangerous. Just is a very high starting current. It's very high. When you find this star delta system, you will find the current. It's very low when you're starting. It's just read 2 or 3 maybe. Just it's very low comparing with the direct connection. It's very low when you're starting, and in this point the connection type changed from star to delta. Then the delta will find it the full current softly. So we prevent a high starting current, this part of the curve, from danger from every motor or the cable or the controlling system. Okay, so it's very good. We solve a very important problem here within a star delta. You have to remember this curve, and according to the soft starter we will find a current it's lowest than, okay, you will find the current more than a star delta. It's maybe 2 for this ratio I over IE. Here we will find it's more a little bit for the current, but it's still safe, not reached for the full current or a high starting current, and it's make a curve and softly starting reaching the point which is a normal point for a current connection here. Then it's softly starting when you reach this point. But in here we will find a critical curve. It's maybe reach a 5 percent, a 5 ratio between I over IE. So there is a very dangerous part according to current, okay, because it's starting within a voltage curve softly, but within a current curve it's not softly. So according to current, the star delta will be more safe and more low or less a current ratio than the soft starter, as it according to this curving between 2. And according to the inverter, a frequency inverter, it's a softly current, and so the frequency inverter is the joker here, is just the joker, because in the frequency inverter we will working according to voltage good, and according to the current it will be good also. When we are looking for the torque characteristics, okay, the torque characteristics in the direct online is very good. It's full torque because it's the full current. It's maybe dangerous current, but according to torque it's very good. It's a perfect curve. When you comparing it according to direct online, it's the minimum torque, and it's a maximum or a normal torque it should work on it. But according to star delta, then we will find the torque very weak, very weak. It's maybe reach more than the minimum torque with a little bit, just a little bit. Then when you're reaching that star still weak, then in this point is a change to connect the delta. It's taking the torque full curve like this path. It's take the torque curve correctly. And when you say that soft starter, it's also starting with a very low torque according it's a certain starting from a 30% from the voltage, so the torque is very low then, and it's changed, and at last in this point reach the full torque curve, and it's very good. But according to torque, still star delta is the joker here. According to the inverter, the torque taking a line just like that. It's take a line, just like that, because I'm controlling the current and controlling the voltage according to frequency. So it's on my hand right now to reach this part. If I have risen up in here or a rising up, but it's direct, it's a direct line, it's a direct line. Okay, so for the high torque characteristics, I find from my view it's safe for the inverter, the frequency inverter, and very safe in the soft starter, and very excellent for the star delta according to cost, and we will talk about the costs right now. So in other comparison, it's a relative starting torque we will find it's 1.5 and 3 mn. It's just half 1 nmn. It's 0.1 mn. It's low here, and here just also low. Okay, it's adjustable torque, okay. And for the features, we just comparing. It's for a direct online, it's a high acceleration with a higher starting current. Okay, it's high mechanical loading, and according to star delta, start up with reduced current and torque, according to these curves. Current and the torque peak at a changeover. Okay, that's to the peak is a change over. Adjustable starting characteristic for the soft starter. Control or run out possible. It's controlling run out possible. It's maybe rising up this curve to reach this place. It's according to me. Okay. A feature for the inverter, or frequency inverter, high torque at low current. It's high torque at low current. Adjustable starting characteristic. Okay, so the frequency inverter here is a joker according to torque, but within costs it's change. Area of application. It's like drives on a stable supply that allowed high starting current torques. According to the star delta, drives that are only subject to load after acceleration up to speed. Okay, it's not a direct acceleration. Here is a direct acceleration. For the soft starter drives that required soft torque progression or a current reduction. For the frequency inverter drives that requirement control soft start and stabilize speed. Okay, let's see other comparison according another things between this is types: direct online, star delta, part winding. Okay, part windings is not for all motor types. Resistors, and it's very complicated circuits, auto transform, and very high cost, but not the same for frequency converter. Okay, slip ring motor, it's a special case, just a special case for the induction motors. Soft starter and frequency converter, or the frequency inverter, it's controlling according to the frequency. Okay, when you find this motor type, direct online is a standard motor well connected. Star delta also standard motor well connected. Part wings, it's 6 wings, just 6 wings motor. For this part wings, it's a special motor. It's a special motor. For resistor, it's a standard also transformer, and we will do the transformer controlling circuit and the next video. Okay, so please see it if you don't. Okay, standard also motor. For a slip ring motor, it's a specific because it's a special case. Soft starter is a standard, and the frequency is a standard. So we have just a new auto transform for a standard motor. It's a new for another comparison in here. According to cost, of course, the lowest cost is direct online. It's the lowest according to cost, because you don't need just a contactor for doing it. Star delta, it's more cost is a little bit. Part we knew it's also a more cost, and this cost according to the motor cost, because it's 6 wings, so its cost is higher than the standard motor. According to resistors, it's very a little bit or more cost a little bit. It's not very, I'm sorry, it's a little bit more. And auto transform is a little bit more also. A slip ring motor is a little bit also. Soft starter is like a same as a slip ring motor, auto transform, and resistor. For a frequency converter is the highest cost. Okay, I'm talking about here inverter, because it's very high cost. So we don't use this inverter for every application. It's just for special applications, and when you need to convert like from a single phase to 3 phase for the connection motor, like that, you're using inverter or a frequency converter. It's just used in a special case, float transfer and something like that. And according motor starting current, it's a 5 or 210 RC for a direct online. For star delta, it's 2 to 3 RC, and it's very good. It's perfect. Okay, part-wing is just 2 RC. Resistors is approximately 4.5 RC, and auto transformers it's 1.7 to 4 RC, and auto transformer in my opinion, as the safe and most a qualified connection type for a motor. Slip ring motor is approximate 2 RC. Soft starter it's 4 to 5 RC, and frequency converter, oh, that man is a joker, is perfect, RC only. So it's perfect. When you say this compression, you know why is inverter is the most high cost. It's the highest cost. Okay, so it's very expensive. Voltage dip, it's high. Okay, for starlet it's high on connection change. في لحظة in the moment of it changing, the connection between star and delta, it's going very high. Okay, path wings is very low, resistors is low, auto transformers low. Okay, according to indirect online, it's low. Slip ring motors low, soft starter is low, and frequency converter approximately is, of course, it's low. Okay, voltage and the current harmonics, we will find a choke here. For direct online it's very high because it's a high, very high current starting, so it's have a lot of harmonics, very high harmonics. Star delta it's moderate, and the path wings it's moderate, and resistor is moderate, auto transform is moderate, slip ring motors is low. Okay, slip ring motor is low, but it's special case which we just say that. Soft starter is high, how, and frequency converter high. And this question here, why does a soft starter have a voltage and current harmonics? Yes, exactly, because of the thyristors. Electronics parts is the most power make harmonics for the voltage, current, and voltage. It's make a lot of harmonics. So it's electronics part. Every equipment have an electronics part. It have a voltage and current harmonics. So we have also for the soft starter and frequency converter have filter for drop this harmonics. A filter it's maybe contained in the soft starter internally, or it's perfect for the frequency converter because it have filters internally, I'm sure, and within have, if it's not have this filter, you should do this filter to avoiding the voltage and current harmonics. So it's very, very important point. According to the power factor, it's low for direct online, and for starlet it's very low also. Part wings is moderate, resistor is moderate, auto transform is low. It's low for auto transform power factor because it's just depending on the motor power factor. It's not rising up the motor power factor. So slip ring motor it's moderate. Okay, soft starter is low because soft starter never controlled the power factor because it's controlling the voltage only. But when you find the joker, you will find the inverter frequency in converter or a frequency inverter. You will find it high because it's controlled within a frequency, so it's maybe rising up the power factor for the motor, and that point is very important. Okay, it's interview question. Numbers of starts available Okay, it's restricted according it's one motor for direct connection. It's 2-3 times more than DOL. Okay, 3 or 4 times more according to the bar windings. Time for more DOL resistors is 3 or 4 times more than DOL. For auto transformer, it's 3 or 4 times more than DOL, as according to the stage of the transformer. Each transformer have a stage, maybe 3 stage. It's 3 times more than DOL, or 4 stage. It's 4 times more than DOL. Slip ring motors, that's 2 or 3 times more DOL, according to slip rings time connection as a special case. Maybe we'll talk about this motor another time. Soft starter, it's limited. Number of stars available is limited because it's starting softly and also shut down softly, and high for the frequency converter. It's high. Okay, high because you can connect more than application. We will define that in other. Available torque, it's approximately 2.5 RT. It's 0.2 to 0.5 RT. For the path wings, it's 2 RT. Resistors, it's the RT. Auto transformers, approximately 0.5 RT. For slip rings motor, approximate is 2 RC. Okay, slip ring motors. Okay, soft starters, approximately 0.5 RT. For the frequency, it's 1.5 to 2 RT. So according to another application, it's also good. Thermal stress, it's very high because the high current. High for start delta because it's changing the contactor moment. Moderated for the bar wings, okay, and resistor, it's very high because there a lot of a stage of resistors when you connect it. Auto transformer is a moderate because it's a free just a step. Slip ring motors is moderate because the ring motors, the ring connected with a cord, the cord of motors. Soft starter is moderate, okay, because it's controlling via the voltage. Okay, it's also exactly, well, you'll find the joker is low. Okay, mechanical shocks. Okay, for mechanical shocks, direct online, here is like it's written in by French, it's très élevé. It's very shocked because it's direct online is shocked with a high current. Star data is moderate, path wings is a moderate, and resistor is moderate. Auto transform is a moderate. Slip rings is low. Okay, soft starter is moderate, and frequency converter is low. Recommended type of load, it's any load, maybe have a direct online, any load. So it's maybe a mechanical load or a tram or something different. Star data is no load. Okay, recommended type of loads. Okay, and just here is any. There in the star data we have no load because of the weakness of the starting within a star, the weakness torque. Okay, so it just one some applications and very special. For the barred wings is ascending torque. Okay, for resistors is pumps and fans. Auto transformers is pumps and fans. Slip ring motors, any slip ring motors can connected with any loop. A soft starter, it's pump and fans. For the inverter, it's any, because the torque is stable. Here in curve we just see it. Okay, high inertia loads, yes, and no for stall delta, no for part weakness. For a resistor is no. For auto transformers is no. Slip rings motor, yes sir. For soft starters is no and yes for inverter. So who's the joker right now? Is that man, frequency converter or the inverter, according to the torque and the starting from 0 voltage and the low current also. The low current also, stable torque and low current and starting from 0 voltage, and also it's a higher, it's highest, it's so expensive according to costs. So we just need to finding more points, and please comment with it in this video. Please subscribe in the channel and don't forget a like, and be my friend on LinkedIn, and thank you for listening, and goodbye in other video. Thank you.